Very good afternoon to all. I welcome you all for this our today's lecture of industrial hydraulics and pneumatic subject. Okay. In the last lecture, we have discussed about the accumulator. It's a types also we have discussed. Okay. And construction, working, advantages, disadvantages of each and every type of accumulator we have discussed. Okay, that is a dead weight loaded type accumulator we have seen. Then we have gone for the spring loaded type accumulator, then gas loaded accumulator, that is hydro pneumatic type of accumulator. In that we have seen two types, separator type and non-separator. Under non-separator again three types we have discussed. Okay, now let us go for the today we'll discuss the one more important element of hydraulic circuit, that is a intensifier, pressure intensifier also you can call. And so here itself I want to clear one thing, is that pressure intensifier is one name. Okay, along with this pressure intensifier you can call it as a pressure booster also for this unit, for this element, okay, component, or this element of hydraulic circuit, pressure intensifier or pressure booster. Getting it? So we'll start with the basic question, that is what is mean by pressure intensifier, or what is the purpose of this pressure intensifier, or why to use this pressure intensifier in the hydraulic circuit. So its answer we'll discuss here. Okay, so before going to start, let me just confirm whether my voice, my screen, my video is everything okay or not. Okay, in the chat box you can just write yes, no, so that I can go further. Okay, whether my voice is audible, whether my screen is visible, whether my video is visible at your end. Okay, please tell me in the chat box yes, no, like. Okay, okay, I got a reply from Pramod, Shubha. Okay, all okay. Thank you. So let us discuss with the definition of the intensifier. Okay, pressure intensifier. So this is a one device in the hydraulic circuit which is used pressure intensifier. Okay, its name, from the name itself will get this meaning, pressure intensifier, to increase. Okay, so this pressure intensifier is a device that is used for is used to increase the pressure in a hydraulic circuit. Okay, please remember, it is used to increase pressure of a fluid in a hydraulic circuit to a higher value. Okay, to a higher value than that of the provided by the pump. Okay, whatever the fluid, okay, pressurized fluid we are getting or provided by the pump, no, so more than that pressure, if you want to increase or if you want to boost the pressure, then to boost or to increase the pressure of the pressurized fluid, for that purpose one device is used and it is called pressure intensifier or pressure booster. Okay, and this device is used only in this hydraulic circuit. For what purpose? To increase the or to boost the pressure, okay, in the hydraulic circuit. Okay, to boost means what? To increase the pressure of the that fluid. Okay, that what are the will get the fluid from the pump, no, so more than that pressure we have to increase. Okay, for example, suppose if you'll get the pressurized fluid, okay, by the pump, suppose it's having value, pressure value is 50 psi or pascal or bar you can consider. If actuator, it is at actuator, if pressure of the fluid is required is 80, that means we have the 50 psi pressure of the fluid, okay, which is provided by the pump, but the requirement is 80. So if you want to increase the pressure of the fluid from 50 value to 80 value, then in the hydraulic circuit we have to install or insert one element or one component or one device. That device is called pressure intensifier or pressure booster. That is a simple function of our pressure intensifier. Getting it? So actually this pressure intensifier, it is also known as the pressure boosters. Okay, once again I am repeating, these pressure intensifiers are also known as pressure boosters, and these devices this device is used to compress the liquid. Now how it is going to increase the pressure? Okay, by compressing the liquid, or that by compressing the fluid in that hydraulic system. Intensifier is the one system. Okay, so in the intensifier, what he will do, they will do the compression of the liquid in that hydraulic system to a value, up to which value? To a value above than the pump discharge pressure. Okay, what are the fluid which is we get at exit or at a discharge of the pump, no? So that then that value, no, we have to increase the pressure. Getting it? And again, in another words, we can tell like this hydraulic intensifier is a device which convert a large volume. Okay, once again I am repeating, hydraulic intensifier is a device which converts a large volume low pressure fluid, low pressure fluid supply or supplied by the pump, no? So that large volume low pressure fluid is going to convert it into the proportionally small volume but high pressure fluid outlet. Okay, small volume, larger or high pressure fluid outlet. That device is called intensified. Okay, so it takes the high volume low pressure flow, that is the fluid pressure from the pump, and it converts the proportionally to this flow with a required low volume but high pressure value. Getting it? That is the meaning of intensifier. Okay, now again, this intensifier, actually this is usually located, okay, where the we can insert, or where we can place this intensifier. So its answer is that this intensifier is usually located in between your pump and the machine. Machine means what? Your hydraulic press or what of the hydraulic crane lift are there, no? So in between that pump and hydraulic machine, in between that you can install this intensifier unit or device. Okay, getting it? So that that crane or the hydraulic lift, whatever they needs higher pressure, no, of your liquid, okay, for the its operation, that you can actually using this intensifier device. Getting it? And this action of this intensifier, no, usually it is similar to that of our step up electrical transformer. Step up electrical transformer. Okay, so the action of the intensifier is similar to that of step up electrical transformer. Getting it? And this intensifier, it finds its application in places where liquid of very high pressure is to be developed, no, from available low pressure. Okay, so in that application or in that places you will get the application of this intensifier. And the typical applications of this intensifier include the hydraulic press, the presses, then riveting machine, and spot welding machines. Okay, or spot welder also you can call. So in that hydraulic circuit or hydraulic application, this pressure intensifier, it is included. Okay, now let us go for the construction and working of the intensifier. Okay, so this is a figure of the operation of a pneumatic, sorry, pressure intensifier. Okay, just a wait. Okay, I have just a look how Okay, so with the help of this figure, I will discuss the construction and operation of the pressure intensifier. Okay, work operation of this pressure intensifier, and this is a typical pressure intensifier. It's a figure I have taken, okay, from our one of textbook of the hydraulics and pneumatic. Okay, so as I have shown in this figure, no, you can see. Okay, just okay. So I was discussing about this operation of a pressure intensifier. So as I have shown in this figure, no. So this intensifier, pressure intensifier unit, it consists of a two piston. You can see it consists of a two piston. Now, where are that? Okay, sorry for disturbance. Okay, so I was discussing about the operation of a pressure intensifier. So as I have shown in this figure, so this intensifier unit, it consists of a two cylinder. You can see here, one is a high pressure intensifier, and here low high pressure piston is located placed here, and low pressure piston is here. Okay, you can see here. Okay, and this large cylinder is there. This intensifier chamber is there. Okay, high pressure piston, and this is intensifier chamber. This is a piston rod. You can see piston rod. So, okay, low pressure piston is here. High pressure piston is here, and for both the piston, it have a common piston rod. Okay, for the both the piston, it has a common piston rod. It is shown here also. Okay, and this the larger this piston is exposed to a pressure from the low pressure pump. Okay, low pressure pump. So whatever the fluid which is provided by the pump, so that you can take inside this intensifier unit from this port. So here you can see we have the port from where you can take low pressure inlet. Low pressure inlet means what? What are the fluid which is we get from the pump? That fluid will have the low pressure as compared to intensifier. Will have the low pressure. So due to that only it is named as a low pressure inlet. So you will get fluid from this port, then it will come at this larger cylinder. Getting it? Larger cylinder. So this low pressure fluid is going to introduced to this larger piston side. This is a large piston side. No, large cylinder. So here in the into this large cylinder or large piston side, the fluid is going to introduce, and thus it forces the piston to move. Okay, it forces to piston to move in this direction. Getting it? And here you have to neglect the losses due to the friction. Okay. What are the losses is there due to the friction that you have to neglect? And this smaller end of the piston, that exerts the same force. Okay, the smaller end of the piston, that exert the same force on this fluid in this intensifier chamber.
Okay, in this small chamber, smaller piston end, this one, it is going to exert same force on this fluid which is going to introduce in this intensifier chamber. Okay, and then from this chamber or from this outlet you will get high pressure outlet, high pressure outlet. Okay, high pressure outlet. So this is the operation of a or pressure intensifier. Okay, now here itself I would like to tell the some advantages of this intensifier. So some of the important advantages of introducing or the employing this pressure booster I will tell. So first advantage is that in hydraulic circuit which requires a low volume high pressure flow over a short period, that time this pressure intensifier you have to eliminate because of its need of expensive or the high pressure pump. Okay, you can add that high pressure pump also. Okay, then unit is actually more compact. This intensifier unit is more compact and simple than the adding another power unit for high pressure cycling. Getting it? Now I will show one small video. Okay, so okay, before that I would like to tell the this is just a pressure intensifier operation we have discussed. I will show the one small type. Here also the same figure is there. Okay, that was the another figure, and this one both are the same. You can see here we you can from this port. Okay, you can take the low pressure inlet. Okay, this is a large pressure piston is there. Sorry, low pressure piston is there. Okay, and here we have the another one. So from this port you can take low pressure fluid, and from this port this high pressure fluid will exit. Okay, and here you can measure what was the pressure at initial stage, what will be a pressure at outlet of the intensifier. Okay, so this with the help of this figure also you can explain the principle of a intensifier. Getting it? Okay, same here. Whatever I have explained that was the single acting intensifier, and this is another figure of the single acting intensifier. Okay, you can see here we have the low pressure chamber. Okay, from this port you can take the low pressure fluid inside. Okay, and here you will get the high pressure chamber. Okay, so you can you will get the outlet that you can give it to the circuit for. Okay, and here I have shown the standard single acting cylinder. Standard symbol of single acting cylinder. You can see single acting intensifier. It's a symbol, standard symbol. I will show the double acting see intensifier also. So double acting. Okay, this side you will get the outlet. Okay, you can see we have this port. From these ports you can take low pressure fluid, and from these two ports you can discharge a high pressure fluid. Okay, so this is a double acting intensifier. Double acting intensifier. Okay, here also I have shown the symbol single acting piston. I have shown. Okay, which was here also same figure, same symbol. This I have shown here. This is a double acting double acting piston. Okay, that is a pressure intensifier. Okay, and this is a air oil intensifier. Air oil intensifier. Now I will show one small video about this. Okay, animation video that is easy to understand you. Just a minute. We are not getting voice.
Hi Professor Vishal Taylor, welcome to my YouTube channel Base Mechanical Engineering. In this video, I teach you hydraulic intensifiers and performance. So hydraulic intensifier is a one type of hydraulic device and it is a full chapters in fluid power engineering in some university. It is as a part of the fluid mechanics. So first we understand the eight function. The functions. Before understanding function, I explain you the meaning of intensifiers. So intensifier means increase the intensity of pressure. Its word itself suggests us to increase the intensity of the pressure of liquid. It is known as the hydraulic intensifier. That means it is a hydraulic device which increase the intensity of any liquid. It's known as the hydraulic intensifiers. So it is already written, it is used to increase the intensity of liquid water by means of energy available from a large quantity of water at a low pressure. So in a hydraulic intensifier, we supplied the low pressure water. By using this low pressure water, we are increasing the intensity of a water. It is known as the hydraulic intensifiers. Next point, where it is to use. So you know that is a different hydraulic device. The different hydraulic devices like the hydraulic press that is used for a bending or a cutting of a different type of the forging instruments. Then the hydraulic crane and hydraulic lift. Hydraulic lift is used to lifting the weight, and the hydraulic crane that is also moving the heavy weight components. So in this all the hydraulic machines, they require the hydraulic liquid which at the higher pressure. So how to achieve these higher pressures? So we use the pump, but they are required to much higher pressure than the pump. Then in between the pump and these different type of hydraulic machines, we are installing the intensifiers. Okay, so hydraulic intensifier is used between the pump and different hydraulic machines like as the press, crane and lift. Why it is used? Because that is not possible to achieve a higher pressure liquid in a pump. That's why we increase the further pressure in an intensifier. That's why the intensifier is used. So that is installed in a different hydraulic machines like as a press, crane and lift. Okay, but it is similar thing is written. This high pressure cannot be obtained from main supply directly. So it is located between the pump and hydraulic machines like crane, lift and press. Next, we learn the working or construction. Before that, I request you to subscribe my channels for watching more video. Like the video and comment on video. Your like and comment give us motivation. Okay, this bottom part is known as the fixed ram cylinder. In this construction there is a main 3 cylinders. Okay, this bottom part is known as the fixed ram cylinder. These all are the cylinder. That means when we seeing from a top, it's look at the circular components. Okay, it's are not the square or that, it is a circular component when we watch from a top view. So this part is known as the fixed ram. Fixed means it's not the moving, its place is fixed. On this fixed ram is surrounded by a sliding ram or cylinder. Means this part is a sliding ram, and this sliding ram means it slide up and down on a fixed ram. Then this sliding ram is surrounded by the large fixed cylinder. Means this sectional component is you see in it is a large fixed cylinders. It is also fixed. That means it does not moving. So we have the 3 cylinder fixed ram cylinders, sliding ram cylinders and the fixed ram. Means 2 fixed. In between two fixed cylinders we are providing the sliding cylinders. Okay, now in this fixed ram cylinder we have a 2 valve. That is a V1 from the low pressure liquid is supplied. Another valve is V2, that is a high pressure liquid supplied to the different machine like the lift, crane. Okay, so high pressure liquid is supplying from here. Now in sliding ram there is a no valve. In a large fixed cylinders there is another 2 valve. That is a valve V3 and valve V4. So these both are, one is inlet and one is the exhaust valve. So here not a high pressure is supply, it is only low pressure liquid from supply here, and again the low pressure liquid is exhaust from this place. Okay, so on the both the end, one is a inlet, one is outlet. Here this is the inlet and this is the outlet. So V1 and V4 is inlet valve and V3 and V2 are the outlet valve. Okay, the sliding cylinder contains the water at the high pressure. So high pressure is achieved in these sliding cylinders. Then after it is supplied to the fixed ram, and through the fixed ram it is supplied to the different hydraulic machines. The large fixed cylinders contains the water from the main supply from here, and it is also exhaust for the valve V3. So these are the construction. In the construction there is a 3 cylinders and different 4 valves, and high pressure is achieved in these sliding cylinders. Next part is the working. So working is started by opening the valve V4. So when the valve V4 is opened, the large quantity of the water at the low pressure is supplied in these large cylinders. Okay, so when we supplying the water in this large cylinder, then what happen? It's acting the pressure on this sliding ram, and sliding ram is moving down and it's reached to the bottom positions. So this sliding ram is come here and it's make the bottom positions. Now after that our real working is started. In that V2 and V4 valve, means this V2 valve and this V4 valve is closed. In 4 valve, one outlet valve is closed and one inlet valve is closed. Okay, in this fixed ram we close the outlet valve, and this ram we close the inlet valve. Okay, so when we supplying the water from V1. Okay, so when we supplying the water from the V1, then the water is start to fill in this sliding ram. Okay, and the sliding ram is start to moving in upwards, and it's move upward, and what happen? The water available in these large fixed cylinders is exhausted through the valve V3. Okay, and it's achieving its topmost positions. and sliding ram cylinders moved upward and it's achieving the more. Then after, then we open the valve V2 and V4, means this V2 valve and V4 valve is open and V1 and V3 is closed. Means earlier case what the valve is open, that is closed, and the whatever is closed, it is now open. Okay, so when the sliding is moved from topmost to downward direction, at that time we achieving this higher pressure and we get achieving the exhaust. Okay, so in this case what happened, we close V1 and V3, means here inlet is closed, here exhaust is closed. Then after, the V2 and V4 is open, so V4 valve is open, so low pressure liquid is start to supply in these fixed cylinders, it acting this pressure on the sliding ram and sliding ram is start to move downwards. When the sliding ram is start to move downwards, it's increase the pressure that is available in the sliding ram and it's achieve the high pressure liquid, and this high pressure liquid is then supplied in a fixed ram, and with the help of the valve V2 it is already open, then it is supplied to high pressure liquid machine, and these machines then after it is supplied the different machine like the lift, crane and that. So these are the simple working. The logic is that here the inlet valve is open, then this inlet valve is closed and outlet is open. So on the one side of the sliding ram suction is takes place, on another side delivery is takes place. These are the simple logic. Okay. Again I request to subscribe my channels. If you learn something, like video and comment on this. Of water from supply to the large fixed cylinders, means this side pressure is available as a P1 pressure and its diameter is
Okay, so this was about the intensifier. Okay, now let us we'll go for the next part, that is a now up till now whatever we cover, that is actuator or the pump, intensifier, accumulator, all are the elements, basic elements of the hydraulic system. Now we'll go for the important element of hydraulic system, that is a controlling element that we will discuss, that is a hydraulic valves. Okay, now these valves are common to hydraulic section also and pneumatic also. Just a bit. Okay, so as I have told that so far we have discussed about the hydraulic pump, okay, which are required for generating the pressure. Then we have discussed about hydraulic actuators, that is the hydraulic cylinders and motors. Okay, the hydraulic actuators are used for converting that pressure into the useful mechanical work. Okay, but to direct and to regulate the pressure and the flow of the fluid from the pump to the actuator, all the hydraulic as well as the pneumatic system requires one controlling unit, and that control unit called control valves. Okay, control valves, that we will discuss now. Okay, that we will discuss now. Okay, once again I am repeating, as we know that hydraulic as we know that hydraulic pumps are required for generating the pressure, getting it, for generating the pressure, that means the will get the hydraulic energy. Okay, from electrical energy it is going to convert into hydraulic energy, that is the purpose of the pump. But hydraulic actuator or the hydraulic motor, okay, that are used for converting the pressure into the useful mechanical work. Okay, pressure into the mechanical use. But to direct and regulate that pressure and the flow of the fluid, which are will get from the pump now to the actuator, for that to direct out to regulate the fluid, to regulate the pressure and flow, to direct and regulate the pressure and the flow of the fluid which is coming from the pump to the actuator. For that purpose, all the hydraulic system as well as pneumatic system, it requires controlling unit, and that controlling unit is called control valve. Okay, and in fact, the efficient function of the entire fluid power system, no, that actually depends on the some extent on the control component, that is the valves, okay, which are used in the that hydraulic or pneumatic system. Getting it? Okay, so although there are significant practical differences between the our pneumatic or hydraulic devices. Okay, mainly in terms of what is the difference between the hydraulic and pneumatic in terms of devices, then mainly in terms of operating pressure and the types of seal. Okay, from that point also you can differ or you can compare pneumatic and hydraulic system. Okay, so the what are the directive that operation of the operation or the principle of the walls or the description of the controlling walls are there now. So everything is same for the both hydraulic as well as pneumatic. Okay, so this is about just a basic background about the controlling unit, that is a valve. But here question arises is that what are the hydraulic valves? What are the hydraulic valves? So the simple definition I will say that the hydraulic valves are devices which are used to control. Okay, hydraulic valves are the devices which are used to control pressure, flow, direction, or flow rate in the hydraulic circuit. Okay, see, the device which is used to control direction, to control flow, to control to control flow direction, then to control the pressure and the flow rate. Okay, in the hydraulic circuit, that device is called the hydraulic valve. Okay, and these control valves utilize normally mechanical motion. Okay, these controlling valves usually utilize the mechanical motion for what purpose? To control the distribution of the hydraulic energy within that circuit, within that system. Okay, getting it? Now this here also I will tell the what is the necessity. Okay, the points I mentioned in the slide, the necessity of this controlling valves. So for that purpose, I have written first the control of the fluid dynamics is essential. As we know that control of the fluid dynamics is essential to ensure efficient or reliable and safe operation of the pumping system. Okay, and this pump puts the fluid in a motion, but it is by adding the some energy to it. Okay, and this kinetic energy is observed as a pressure, no, that is going to carry it in the fluid, and then slowly it will lost to the function, sorry, to the friction in the piping system. Okay, so we need to control direction, to flow direction. We need to control the flow direction. We need to control the pressure, and we need to control the flow rate also. For that purpose, one device is required in the hydraulic circuit or in the pneumatic circuit or the system, and that device is called a control valve. Okay, now these controls all actually are these control valves are classified into three basic types. Okay, again this classification has been made based on their function in the hydraulic system. Based on the function in the hydraulic system, these these control valves are divided into the three categories. So you can see the first is the direction control valve, then pressure control valve, and the flow control. Okay, pressure control valve, flow control valve, direction control valve. Getting it? So these are the three basic types of the control valve based on their function. Okay, these are the three same for pneumatic as well as hydraulic system. Getting it? And further, these controls all are divided further, are divided into subtype also, and these types also I have mentioned here. So you can see that in detail we are going to see one by one. Okay, so the direction controls all are divided, are classified into subtype. like 2x2, 3x2, 4x3 wall, then manually operated direction control, solenoid operated, depending on the wall actuation mechanism. It is divided into manual operation, solenoid operation, operated, then pilot operated, then cartridge of walls are there, then check wall. In that check wall, we are going to see directly operated and pilot operated. So these are the subtypes of the direction control wall. Here also we have the types of the pressure control wall also. So pressure control are classified into the mainly pressure relief wall, then pressure reducing wall, then counterbalancing wall is there, sequencing wall is there, unloading wall. These are pressure control walls. Each and every wall we are going to discuss in detail. We are going to see its working, operation, everything along with the figure, okay, and along with the standard symbol also. Then flow control. Again, this flow control are classified into the three, that is non-compensated flow control, pressure compensated flow control, temperature compensated flow control. Okay, in detail we are going to discuss. Don't worry. Okay, so these are the three basic types based on the their function in the hydraulic system. Now, based on the method of actuation of that wall, method of actuation of the wall, these control walls are divided into the three types, which are divided into four types, which are that four types: directed operated control wall, then pilot operated control wall is there, manual operated control wall is there. Okay, based on the actuation, method of actuation, and electrically operated, that solenoid, that directed operated, pilot operated, manual operated, electrical operated. These are the actually methods of the actuation of the controller. Okay, based on that only it is classified into these four. Okay, now again, okay, this is a very important point of classification. Then further, these fluid control walls are classified into again three types based on their configuration or modes of operation. Okay. Now in that again, these are the three essential types. So based on the based on the configuration or modes of the operation, these control walls again classified into three types. One is the poppet or seat walls. Then second is the sliding spool walls, and third one is the rotary spool walls. Okay. So before going to that direction control wall, pressure control wall, flow control wall, firstly we'll go for these walls. Okay. Based on their configuration. Okay, so this is a first, that is a poppet or seat wall. Okay, so here I will just give a brief from this figure, a brief understanding of these walls. Okay, which are based on the configuration. That we'll discuss. Okay, before going to discuss the construction and working of different types of the control wall. Let us have a brief understanding of this wall configuration. Okay, so firstly we'll go for the poppet or the seat wall. So with the help, you can see this is a figure of the construction of the poppet wall. So the most common form of the poppet wall is I have shown here. Okay, you can see. So from this port, okay, so normally this wall, it is actually this poppet wall. Actually, it is normally it is in the closed condition. Okay, due to that only there is no connection between your port A and port 1 and 2, as this poppet wall or seat wall normally it is closed. Due to that only there is no connection between the port 1 and port 2. But in this poppet walls, ball or disc or cones are used. You can see ball or disc or cones. You here in this figure you can see ball is used. So balls, disc or cones are used for what purpose? In conjunction with this wall sheet. Okay, in conjunction with the wall sheet. Okay, for what purpose it is used? To control the flow. To control the flow. Okay, and here I have shown in this figure ball. Okay, so when how it works, no? How that whether screen is not visible? Hello, whether screen is not visible? Hello, please tell me.
Visible, sir.
Visible, no? Because I have another device, or through that device also I am checking. My from this device it is visible. Shubham, please check once again. Shubham Singhal, please check. Now visible. Okay. I was talking about this poppet wall. So normally this port in the poppet wall, this port A, that is port 1 and port 2. Okay, there is no connection between this because in normal condition it is closed. And to control the direction, to control the flow, of the fluid, normally in this poppet wall, balls or disc or cones are used. Okay, are used in conjunction with this seat wall. Okay, in conjunction with the this wall sheet. Okay, here wall sheet is there. Okay, so what is the operation that also will do? So when this push button is there, no, when you will press no this push button, that time this ball is going to push, okay, to this spring. Okay, if you press this push button, no, when push button is pressed, that time this ball is pushed. This ball is pushed out of its seat. This is seat, no, so it is going to go in downward direction, and hence due to that only flow is permitted from this port 1 to towards this port 2. Okay, बॉल जर खाली आला तर काय होणार हो, सीट स्प्रिंग कॉम्प्रेस होणार आणि त्या टाइमला इथले सीट वॉल जे आहे ना, सीट जे असणार आहे ते ओपन होणार. दॅट मीन्स फ्लुइड विल गो फ्रॉम दिस पोर्ट 1 to towards this port 2. Okay, and when you will release this push button, no, that time spring will return to its original position. That means this, what are the position I have shown, no? So that time this wall will take this position. Okay, and that time seat, okay, will close, okay, due to that ball. Okay, and this from port 2 fluid will go. Okay, so that is a poppet or seat wall. Getting it? Actually, where it is used, that also. So this poppet wall are essentially in a two-way walls. Okay, it is essentially as a two-way wall. Okay, for example, if fluid will come from port to 2, no, and if you push this button, no, that time ball will go in the downward direction. That time port from this port to what are the fluids going to come, no, that will come towards the port A, because ball will be at downward position. Okay, okay, and when if you release the push button, that time again it will return to its original position. Okay, so these poppet walls are essentially as a two-way walls, and therefore they are limited for the application in which flow reverse is not possible. Okay, that means only one direction. If you require that time, these walls are not used. Okay, so that time You can go for the check wall or relief wall. Okay. Applications in which flow reversal is not required. Okay. So there you can use this puppet wall. Okay. That is check wall or the relief wall. Again, low power application. In that for that applications also you can use this puppet wall because of their relatively high leakage rates. Okay. This is a puppet wall. I will show another one. Sliding pull. Okay. You can see from port. So with the help of this typical sliding spool wall, I will explain. So you can see here spool will move horizontally. Okay. This spool means what? This piston rod you can see. Okay. So this spool will going to move in horizontal direction within this wall only. This wall, okay, this within this wall body, it will move in horizontally for our purpose to control the flow. Okay, this rivalry area called this land, no, that will blocks or that will open this port A or port 1 or port 3. Okay, to give the record operation, that time it will open and close. I will show one animation also. Okay, so here you can see the figure 1, that's A, spool position 1. I will show. So here the fluid supply is connected to the your port 1, and now port here fluid 3 is closed. Okay, that means fluid will come through this port 1. That time port 3 is closed. Okay, thus the flow will permitted to go out from this port 2. Okay, port 1 मधून fluid येणार and port 2 मधून जाणार. Okay, now when this port 1 is closed, no, that time, okay, this you can see this position. Okay, that time spool is moved towards this left side. Getting it? That means fluid supply is cut off. Okay, and this port 2 is connected to this your port 3. Okay, thus fluid flow is permitted from port 2 to 3. That means fluid will come from this port 2 and it will go through the port 3. Okay, this is a sliding spool. I will show one small video for this. Wait. Firstly, we'll go for the ball sheet.
Sir, voice is not audible.
Okay. Okay, this is a pop-it wall. You can see inlet port, outlet port. So when, okay, just see on screen. When you will push that button, then port 1 will and by releasing that button, ball will take its original position. That means there will not be any connection between port 1 and port 2. Okay. Now I will show another one video that is related to the sliding. Oh, sorry. It's a sliding wall. You will come and port to 2, you will go outside. When you will move towards the left, that time from port 2 you will come, and from port 3 you will go outside. This is the direction. And we will see the rotary spool also. Port 1, it will go from port 4. From 2, port number 2, and you will go from port 3. This is the first position. This is the rotary spool. Then, second position. See, from port 4. You will come and you will go from port 2, and from port 3 you will come, and port 4, from port 4 you will go outside. Okay, about position 4. 2 position 4 point. Okay, 2 position 4 point. Okay, so this is about the sliding spool wall and rotary spool wall. Okay. Now what are the control walls are there? No, that we will that pressure control, direction control, and flow control, that we will discuss in the next lecture. Okay. So I request you all, please write down your roll number in the chat box, and after writing your roll number, you can leave this meeting. Thank you. Okay. See you tomorrow. All are requested to write your roll number in the chat box. Then you can leave this meeting. Okay, be fast. Komal Gantade, Rahul Chaudhary, Ajay Sukale, Bhupendra Sondakke, Shubham Gandole. Please write down your roll number. Be fast. Okay.